Good everyone, and welcome back to our tutorial. Today we're talking about the rules of differentiation. There are different rules of differentiation. We have the product rule, we have the quotient rule, the constant rule, sum and difference rule, and so many other rules. So you just pay attention. Like I said, nothing is too difficult, nothing is too complex. You just need to pay attention and you will get it. So let's dive into the business of today and see what we have. Now we can see what we have here. Now, this is the topic rules of differentiation. We have them here. Now we look at the constant rule. It said this rule tells us that when we differentiate a plain number that does not have a variable attached to it, the derivative of that number is zero. This is because differentiation is the rate of change. A constant number does not change, so its rate of change is zero. So derivative of 5 or any other number is zero. That's what it means. Now, what that is telling us that the derivative of that number does not change. Derivative of 5, 4, 6, any number that does not have a variable attached to it, that number is zero. The rate of that number is zero. Rate of change of that number is zero because it's a constant, it does not change. Okay, thank you. Let's move to the next one. Next is our power rule. We say the power rule. When the variable of x When the variable x is raised to a power, you multiply the powers by the coefficient of x and then subtract 1 from the original power. What it's saying is, now you can see we have x raised to power 4. X is raised to power 4. You multiply x by the coefficient of x. You multiply 4 by the coefficient of x, which is what? 1. The coefficient of x is 1 in this formula. So we now say 4 times 1 is 4. That's how we have the 4x. Then raised to power, we just said what is reduced by 1, right? So 4 minus 1 is 3. That's how we got the 4x raised to power 3. Now we move to the next one, sum and difference rule. We said when we use this when we have separate terms added or subtracted. Now this is the formula that we are to use. Derivative of u plus or minus v is equals to du dx plus or minus dv dx. Now example, we have f of x is x cubed plus x squared. Now we differentiate our u is now x cubed and our v is now x squared. So we differentiate them individually and we add them together because this requires addition, right? So our du here is 3x squared because we had 3x cubed. From our power law, we said you multiply the power by the coefficient of x and you reduce it by 1. So when you multiply 3 by the coefficient of x, which is 1, you have 3x, and now you reduce it by 1. So 3 minus 1 is 2, so you have 3x squared. Now dv, we have x raised to power 2. X raised to power 2 now, using the power law again, you multiply 2 by the coefficient of what? X. So when you multiply the 2 by the coefficient of x is 1, so you have 2x, and you reduce your 2 by 1. So your 2 minus 1 is 1. So you have x, and then t raised to power 1 is that thing, so you have 2x. So now the final answer, f prime of x is equal to 3x squared plus 2. You add them together. That's how to go about it. Now we'll move next to the next one, product rule. We said when two different expressions are multiplying each other, you cannot just differentiate them separately. We differentiate the first part by the derivative of the second and add to the second part multiplied by the derivative of the first part. Now let me explain what this means. Now let me explain what that means. It means if you have two expressions now and you want to multiply them, you want to find the derivative of that multiplication, you don't just differentiate them immediately. You first of all take the first part, get the derivative of the second part, Then you multiply the two of them together. Then you now add it to the product of the second part. Now the second part, the product of the second part and the derivative of the first part. I don't know if you get me. Now, if what I'm saying is if u it's let's say 3x squared and v is 5x. Now, you want to get the derivative of that product. Now, you first of all say u, you bring out the u multiplied by the derivative of v plus v multiplied by the derivative of u. That's what I'm saying. I'll show you in the notebook so that you understand what I'm saying. But I don't know if you catch what I just said right now. Let's proceed to the note, please. Now you can see this example. This is the formula u dv plus v du. So first of all, when you are given a problem, you differentiate both the u and the v and you apply this formula. This is the formula that you use. Now example, f of x is equal to x squared multiplied by x plus 1. The bracket means multiplication, I'm sure you know. We now say let u be equals to x squared and v equal to x plus 1. So now our du dx is equal to 2x. 2x. Our dv now 2x. Now we said our du dx because we have x raised to power 2 like we said in our product law, right? Product rule. We have 2x here. Now dv dx is equal to 1 because when you differentiate x you have 1. You say 1 multiply by this coefficient of x, it will give us 1. And 1 times x is x. 1 times x is x. And now we reduce the power by 1. So 1 minus 1 is 0. And anything raised to power 0 is 1. That's how we got 1 here. And now when you differentiate a constant like we said plus, it's 0. So 1 plus 0 is 1. That's how we got it. Now bring all of that into this formula. U dv dx plus v du dx. So what's our u? X squared. And what's our dv dx? It's 1. Plus our v. What's our v? X plus 1. And what's our du dx? It's what? 2x. Yeah. So x squared multiplied by 1 is what? X squared plus, now open the bracket, x multiplied by 2x is 2x squared and 1 multiplied by 2x is 2x. So this is the final answer. When you now get it, now x squared plus 2x plus 2 x squared plus 2x squared is 3x squared because they are like terms. We have 3x squared and plus 2x. That's how we got this. Now our quotient rule, we said this is used when expression is divided by another. This is the formula to use for our quotient rule. We move straight down to chain rule. It's a chain rule. This is used when a function is inside another function. Now the rule of this is take the derivative of the outer function first, leaving the inner function alone, and then multiply it by the derivative of the inner function. Example, f of x is equals to 3x plus 1 into raised to power 2. So now we say let u be equals to 3x. So we say y is now equals to what? 3x plus 1 raised to power 2. Now formula dy dx is equals to du dx times dy over du. Now our u is equals to 3x. So instead of 3x plus 1 squared, it will now be u squared, which when we differentiate it to give us 2u, and 2u is equals to 2 bracket 3x plus 1. And when you open the bracket, we have what? 6x plus 1, which is our dy du. Now Our u is equals to 3x plus 1. Then when you differentiate that, you have 3, because differentiating 1 is 0, and when you differentiate 3x, you have 3. Now dy dx will now be equals to du dx times dy du, which is equal to 3 times 6x plus 1. And when you multiply through, you get 3 times 6 is 18, and 3 times 1 is 3. So we have 18x plus 1. So basically, these are the rules that we use in a differentiation. Okay, there are other rules that we can apply in terms of implicit differentiation and all of that, but for now, this is the main major rules that we'll be using day to day, that will be seen on mostly all our equations and problem solving and all of that. All right, thank you so much for your time, and I pray you have understand everything we've said here. Please, if you don't understand, please drop a question on the WhatsApp group. Please drop a question the same way you drop your answers and everything. You can still drop your question, and it will be attended to ASAP. All right, thank you, and God bless you.
Quiz.